How do I choose a good password? Boy, the number of times we run into this, and it seems like the rules are almost always changing. In a sense, they are. And unfortunately, many of the services we use continue to use old rules that aren't sufficiently secure. And many of our older passwords that were secure once upon a time, they're not. Not anymore. How do I choose a good password? Password security has never been more important. With occasional security breaches at service providers and rampant email account theft, make sure you're choosing and using secure passwords. I'm Leo Notenboom. This is AskLeo.com. We frequently hear of major websites suffering data breaches that expose millions of user accounts and passwords to hackers. This type of theft makes the concept of good passwords all that much more important to understand. Moving target. What makes a password good constantly changes, perhaps in ways you wouldn't expect. To understand what makes a good password, we need to understand what makes passwords vulnerable, which means understanding a couple of ways that hackers hack. Along the way, I'll also discuss hashes and why a salted hash isn't breakfast food, but rather a critically important approach websites should be using to keep track of your passwords. And there will be rainbows. Caveat. I'm not a security guru. The concepts I describe here aren't intended to make you one either. Things are most definitely simplified, often oversimplified to make a point or explain basic concepts. The devil is in the details, and you won't find it here. My goal is simply to explain how and why passwords are so darned important, and why the password you think is strong enough probably isn't, and what you need to do about it all. If you're designing a website and are looking for what you need to do to keep passwords secure, you've come to the wrong place. If you're an average computer user and you just want to keep your online life secure, then follow the new rules to the left and keep your computer safe. If you're curious as to how some of this stuff works at a high level, read on. The rules, old and new. For those with short attention spans, I'll start with what you need to do differently beginning yesterday. In the past, the traditional advice on passwords was 8 characters long, minimally. Never use names or words, at least not without mangling them somehow. Never use combinations of names or words, at least without mangling them somehow. Use a combination of upper and lowercase letters and digits. Use at least one special character, something other than a letter or digit, if the system will let you. Those rules are no longer sufficient. Even if you carefully follow them all, you're left with a password that remains very susceptible to many types of compromises. Instead, 12 characters long at a minimum. I recommend 16 and use 20 myself when possible. Longer is always better. Use a combination of upper and lowercase letters and digits. Words aren't quite as evil as they once were as long as the password is long enough. Consider padding the password with a random character to make it even longer. As you can see, there's a new emphasis on length. If you remember nothing else from this article, let it be this. Size matters. Longer is better. The dictionary attack. One reason we were told never to use normal words or common names in passwords is that there are simple attacks called dictionary attacks that try all words or all combinations of words one after the other until something works. Many attackers jumpstart this process by starting with a list of known common passwords or words used in passwords. The Oxford Dictionary tells us this suggests that there are at the very least 250,000 distinct English words. If we stick to single case, upper or lower, just not mixed, then a program needs to try only 250,000 times 250,000, 62.5 million, times to be guaranteed to stumble onto a 2-word password. I say only 62.5 million because to a computer running with speeds measured in billions of operations a second, that's nothing. Yes, you can add names and random capitalization to the mix and perhaps even insert digits, but even that slightly obfuscated dictionary-based approach to password cracking is easily performed by today's technology. It's also not necessary anymore. It's now quite possible for hackers to try literally everything. The brute force attack. Let's say you've been really good and you have an 8-character password made up of completely random letters, numbers, and symbols. Perhaps 7CXX ampersand star XF. That's a good password. Perhaps the best you can do in 8 characters, but it's not a great password. It's estimated that such a password could be cracked offline in a little over 18 hours. It doesn't matter that you didn't use words or your name or anything else. 8 characters, 6,704,780,954,517,120 possible combinations and passwords can be hacked in less than a day. Now, the most common response I get is, how can they try that many that fast when I get locked out after getting it wrong 3 times? Online attacks. The attacks I've described so far all involve the hacker having a stolen copy of some user account database that they can access on their own computers offline. This allows them to attempt to crack it at extremely high speed, as fast as their computers allow. In the online scenario, actually accessing the service directly attempting to break in, you can't try nearly that fast. However, they can use other techniques to try fast enough to still be a serious issue. For example, consider a botnet of hundreds of thousands of computers across the globe performing a distributed dictionary attack against a set of email accounts. Slowly, patiently, and from different locations so as not to trip any limit filters, they try millions of passwords against hundreds of thousands of accounts. Eventually, they'll hit pay dirt, especially if they try those most common passwords first. Surprisingly, that's not why 8 characters is too short. A truly random 8-character password will probably protect you just fine from these types of online attacks. It's the offline attack you need to worry about, where your 8-character password, any 8-character password, might be cracked in microseconds. To understand how that can be, we need to understand how passwords are stored. But first, we need to realize that guessing from the outside is only one way to get password information, and it's no longer the most common. The database breach. Every so often, we hear of an online service that has been hacked into and had their database stolen. What that usually means is that rather than trying to guess logins one at a time, a hacker has infiltrated the systems of the service and snatched a copy of some or all of the user account's database. As a result, they typically have a list of all usernames or login IDs for that system, a companion list of password information for those login IDs, other stuff that the system may have stored for each login ID. No need to try guessing passwords slowly from the system's public-facing login. The hackers walk away with almost all the information they need in one fell swoop. Note I said password information above. Properly secured systems don't store your password. They store something else. Hash. Hold the salt. What a secure system stores instead of your password is called a hash of the password. A hash is a mathematical function that takes an arbitrary amount of text and computes a number from it. The number has the following characteristics. Any change, however small, in the data being hashed should result in a large change in the resulting hash. It should never be possible to reconstruct the original data from its hash value. It's not feasible to craft data that, when hashed, would generate a specific hash value. So, instead of storing your password, quote, I forgot, quote, the system might instead store a very long number that I'm not going to read. That's the result of an SHA-256 hashing function. Anytime you give that function, quote, I forgot, quote, SHA-256 will return that number, which happens to be 256 bits long. This is important. Given only the hash, there's no feasible way to figure out what the password caused it to be generated. Hence, it's often called a one-way hash. When you log in, the system passes whatever you type in as your password through the hashing function, and if the resulting number matches, then you must have typed the correct password, because it's the only thing that could generate that number. Your actual password is never stored. Unfortunately, as technology has grown more powerful, we've run into an interesting issue that puts this technique at risk anyway. Rainbow tables. Consider the 8-character password. If the password we choose allows each character to be any of 26 alphabetic upper and lowercase characters, 10 digits, and 10 special characters, that's 72 possible characters in each position. If we have 8 of those, that's 72 to the 8th power, or 722,204,136,308,736. 722 trillion possibilities. It sounds like an enormity, but with today's computational and storage power, with a stolen database and an offline attack, it is possible to calculate all possible 8-character passwords, calculate the hash value for every possible 8-character password, store that in a massive table saved on disk. Cracking a password from a stolen database is just looking up the hash value you got from the database and fetching the corresponding password. This type of table is called a rainbow table. In reality, hackers rarely need the entire table. People tend to pick bad passwords, so a smaller table with the hash values of lots and lots of common passwords is enough to crack a huge number of accounts. The hashing algorithms used are often quite standard. So, if your email service, your social media service, your photo sharing service, and whatever else you log into all use the same hashing algorithm, they'll all store exactly the same hash value for your password. If that table of password hashes is ever stolen, then a quick lookup in a rainbow table will retrieve your password. Then the hackers can try it at any of those other sites, even though they were never directly breached. As it turns out, there's a trivial way to stop that possibility. Add seasoning. The salted hash. Salting is a way to obscure the information stored in a service's password database. Instead of computing the hash of a password, they add something to the password and hash the combination. Then, when the time comes to check that you've entered the right password, they take what you've typed in, add that same something to it, and hash the result. If the hash value matches, then the password is correct. For example, perhaps I create my password as, quote, I forgot, quote. As we saw, that gave us an SHA-256 hash of a very long number I'm not going to read. If, however, the system storing my password automatically adds, quote, my pants, quote, to every password and hashes the result, quote, I forgot my pants, quote, the hashed value is completely different. Again, a completely different number that I'm not going to read. When I come back to log in and enter I forgot, the system automatically adds my pants and hashes that, and the values match. If that hash value is ever in a rainbow table somewhere, it maps to I forgot my pants, which is most decidedly not my password. The item we add, in the example above, the frivolous my pants, is known as salt, as it changes the flavor of the result of the hash function. In reality, it wouldn't be anything so simple and would vary from system to system, and if done really well, from account to account. Now, with all that as backdrop, here's the kicker. You don't know how the services you use encode your password, and too many do not use salt. In fact, a recent breach at an extremely well-known large online service exposed the fact that they were not using salt at all to secure their database of hashed passwords. The stolen passwords could easily be looked up via rainbow tables. So, in the face of not knowing which services do password security correctly, how do you protect yourself? Size matters. The single most important thing you can do to improve your password's security is to make it longer. The longer the better, in fact. Recall how I said an 8-character password gave us 722 trillion possible combinations? 722 trillion, 204,136,308,736 to be exact. A 12-character password results in, well, a very long number I'm not going to read, possible combinations. There's no rainbow table big enough for that, and there won't be for quite some time. Short of storing your password unencrypted, which is a huge security no-no anyway, just about any hash will do, salted or not. As a bonus, it's extremely unlikely that a dictionary attack will bother with the assorted combinations to eventually get to whatever it is you put in 12 characters. Length doesn't imply complexity. There's a very strong argument that says asterisk, 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 password, asterisk, 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 is in fact a significantly more secure password than 7CXX ampersand asterisk XF. Plus, it's easier to remember. Although using normal words in this manner still makes me nervous for reasons I can't quite explain. In fact, even longer pass phrases, something like correct horse battery staple, are perhaps best of all, with a big hat tip and a propeller twirl to that great geeky webcomic XKCD. The bottom line, this time at the bottom. So, what should you do? Abandon 8-character passwords. They should no longer be considered secure, period. Make all passwords 12 characters or longer. You can make a password longer and more secure by adding repeating characters if you can't think of anything else. That's the bare minimum. For bonus points, make your passwords 16 characters or longer. Again, I use 20 characters myself whenever possible. Use a password generator, such as that included with many password vaults, to make it a 16-character or longer random password. Never use the same password in more than one place. If, for some reason, an ID and password gets compromised at service A, hackers will then run around to many other services and see if they can log in with it. All too frequently, they can. Consider using a password vault like LastPass to remember all your unique passwords for you. And of course, keep your PC secure. No matter how strong your password, malware such as keyloggers can capture it, and using an open Wi-Fi hotspot without proper security could be the moral equivalent of writing your password on the wall for all to see. For links related to this article or to leave a comment, visit askleo.com/5440. I'm Leo Notenboom, and this is AskLeo.com. Thanks for watching.